Hello, Legacy students. So today we're going to look at solving absolute value equations and inequalities. So we looked at the graphs. So now we're going to want to look at how do you solve these kind of problems. You're going to want your notes, pen or pencil, and calculator. And also, if you are currently not listening to me talking right now, you are going to be super confused. So please make sure that you are listening to me talk on this video. So what do you already know? We already know that absolute value means that represents the distance from 0, right? We know if we plug anything positive into there, you get the positive back out. So absolute value of 3 means 3, and absolute value of -3 equals 3, because -3 and 3 are both 3 units away from 0. So what you're going to need to do to solve an equation that contains an absolute value. Let's think of it using the graph. So I have this x plus 2 equals 5. So basically, let's graph x plus 2, absolute value of x plus 2. So you remember, plus 2 inside the absolute value bars moved your v to the left, right? So let's move our v to the left here. And then I'm going to go up 1 over 1 on both sides. Like that. And like that. So now what it's saying is, where is this equal to 5? So on the y-axis, I'm going to put a line here at 5. Right there. So notice this hit twice. One right there and one right there. So my two answers would be -7 and 3. Right? That's where my graph hit at 5. So we're not going to want to use our graph every single dang time. It's going to take us forever to do these problems. So let's figure it out using just plain math. So I have 5x minus 10 equals 45. So now what you're going to do is you're going to set up two problems. One for that negative sloping side of our v, and one for the positive sloping side of the v. That's going to make it look like this. So basically, I'm going to set up my problem, negative 5x minus 10 equals 45. That's one side of this problem. The other side is basically the negative version of that problem. Okay? So let's solve this side like we normally would solve. So it looks like we need to add 10 first. So we'll be left with 5x, and 45 plus 10 is 55. Let's divide by 5 on both sides. So it looks like x equals 11. Now, let's plug that 11 in. Let's make sure it's right. So I'll get 5 times 11 minus 10. So that's 55 minus 10, which is 35. Ain't it? That's 45. So yeah, and that's 45, right? And 45 absolute value equals 45. So this one works perfect. Let's do this problem. So now what you're going to basically do, that's technically a -1. So let's give that -1 in. So I'll get -5x plus 10 equals 45. So now let's solve this problem. Subtract 10 from both sides. Get -5x equals 35. Let's divide by -5. So I'll get x equals -7. So let's plug in that -7. Is it going to work for us? So I'll get 5 times -7 minus 10. Well, that's -35 minus 10, right? That's -45. Absolute value, though, right? Because this is in the absolute value bars. So that's just 45. 45 equals 45. So this one checks out. One thing you're always going to want to do, you're going to always want to check out for when you're doing equations, you're going to want to check the answer you get. No problem of your own, but sometimes you get a problem or an answer that just doesn't work in the answer. Let's take a look at an example here. So I got 2x plus 12 equals 4x. So you're going to do the same thing as what we did. You're going to rewrite this without the absolute value bars into two different problems. So I'm going to have 2x plus 12 equals 4x and negative 2x plus 12 equals 4x. Okay? Let's subtract 2x. So I'll get 12 equals 2x, divide by 2. I'll get x equals 6. Now, let's make sure it works. So I'll get 2 times 6 plus 12 in the absolute value bars equals 4 times 6. Well, 2 times 6, that's 12. This is 24. Absolute value of 24 equals 24. Well, that checks out. No problems there. Let's check this problem. So I'm going to distribute that negative 2 or that negative into my problem here. Whoops, almost forgot the 1 there. Let's add 2x to both sides. Divide by 6. So that's negative 2 equals x. Let's plug that one in. So 2 times negative 2 plus 12 equals 4 times negative 2. Well, that's negative 4 plus 12, right? Equals negative 8. Negative 4 plus 12, well, that's just 8. So 8 equals negative 8. Did I do anything wrong? Distributed my negative in. Added 2x. I didn't do anything wrong. This is when math kind of pulls a gotcha moment. And it says, you got the answer, but hey, it doesn't work in the problem. So what you're going to want to do is make sure you show me that you know it doesn't work. So put a big X or put doesn't work or something like that, okay? So make sure you kind of make a little note saying, hey, tried it, doesn't work, sorry Marsh, okay? Just keep that in mind when you're checking your answers and you get a wrong, something that doesn't make sense, like 8 equals negative 8. Now, let's also look at inequalities. So equations look something like that, inequalities look something like that. So how are you going to change your approach to solve? Let's try the graphing thing again. So I got x minus 2 is less than 4. So on my graph here, I'm going to go to the right 2, because remember, inside makes you go left or right. Let's go ahead and go like this. Go ahead and go like that. So at 4, right here. So now you want the graph that's less than 4. So it looks like that all my x values that are less than 4 looks like it's between negative 2 and 6, right? So we would write it something like that, or an and inequality, because it's covering all these pieces of the graph, right? From here and here. What about if I want something greater than? So let's move, it looks like it's the left one. Let's go ahead and do up 1 over 1 on both sides here. There we go. And we're going to sit at 3. Now, they want everything that's greater than 3. So I want this piece, so it looks like starting at negative 4, right? And going that way. And starting at 2 and going that way. So we want everything, x needs to be less than negative 4, or x needs to be greater than or equal to 2. Who would have known? And an or comes to makes a comeback. So let's keep that in mind and let's do this problem here. So I got 4x plus 5 in the absolute value bars plus 3 is greater than 16. Alright, so very first thing I notice, I have this plus 3 on the outside of the these absolute values, don't I? Notice none of them did. What you're always going to want to make sure you do is kick this out. Get rid of it. You can't have anything with the absolute value bars. It has to be alone. So this has to be alone. So let's subtract that 3 first. So I'll get 4x plus 5 equals 13. Now what I can do is make my two problems. So I got 4x plus 5 is greater than 13, and negative 4x plus 5 is greater than 13. It's greater than. There we go. Now let's solve here. So I'm going to subtract 5. Get 4x is greater than 8. Let's divide by 4. So x is greater than 2. Let's check this one. So let's distribute that negative in. Looks like I got to add 5. Divide by negative 4. Well, I divide by a negative. Make sure you flip that sign. So I get negative 9 over 2. Let's graph that. Let's see what kind of, are we going to get an and or an or on this problem? So let's graph that on my number line. So I have negative 9 over 2 over here, 2 over here, both open dots, right? Because it's just greater than or less than. X is greater than 2, and it's pointing to the right, so it looks like I'm going to shade on that side. And x is less than negative 9 over 2, so less than is going to go that way. Remember, if they go away from each other, you're going to have a or inequality. So you're going to want to write your answer as x is greater than 2 or x is less than negative 9 over 2. And that's the end of this video. See you later, Sabers.